Hello students, myself Archana Varude. In last video, we have already studied about two types of modulus of elasticity. That is, first is Young's modulus and second is bulk modulus. And after watching this video, you will be able to understand the third type of modulus of elasticity, that is known as modulus of rigidity. Then relation between Young's modulus, bulk modulus and modulus of rigidity, and how the wire behaves when continuously force is applied on it. Now we first see the third type of modulus of elasticity, which is known as modulus of rigidity, and the symbol used to denote modulus of rigidity is called as eta. And if we take the ratio of third type of stress and third type of strain, that is shearing stress and shearing strain, and if that load is applied, it is within limit, then that ratio is called as modulus of rigidity. And therefore, from that we write the definition of modulus of rigidity is within elastic limit, the ratio of shearing stress to shearing strain is called modulus of rigidity. Then we write the formula, and formula is eta equals to shearing stress upon shearing strain. Then write the formula for shearing stress. Shearing stress formula is F upon A. Upon formula for shearing strain is lateral displacement of any layer with respect to its distance from fixed layer. And as we know that if there is very small change in shape and size of object, then that ratio lateral displacement of any layer with respect to its distance from fixed layer is equals to tan theta. But if theta is very small, then we write eta equals to F upon A upon tan theta. But if theta is very small, then tan theta is equals to theta, and therefore formula for modulus of rigidity is eta equals to F upon A theta, where F means applied force, A means area, and theta means angle. Then we write SI or MKS unit of modulus of rigidity. Formula is, that is shear stress upon shear strain, but we know that for shearing strain there is no unit because it is the ratio of two similar quantities, and therefore when we write SI or MKS unit of modulus of rigidity, it is equal to the SI or MKS unit of shear stress, and SI unit of shear stress is Newton per meter square. Then CH unit of modulus of rigidity. Here formula is same, that is shear stress upon shear strain, and again we write CH unit of shear stress, and that unit is dyne per centimeter square, and shearing strain has no unit. Then what is the relation between Y, K and eta? Where Y means Young's modulus, K means bulk modulus, and eta means modulus of rigidity. And here this formula gives the relation between Y, K and eta, and that formula is Y equals to 9 eta K upon 3K plus eta, where Y is Young's modulus of elasticity, K is bulk modulus of elasticity, and eta is modulus of rigidity. Now we see stress strain diagram, or it is also known as behavior of metal wire under continuously increasing load. That means here we observe from this diagram, if that continuously force is applied, then what are the changes in that length of wire. Okay, here on this graph, on x-axis strain is considered, and on y-axis stress is considered. And here it is observed that here this O point, this is the original and this is E point. It is a straight line and this straight line indicates that the stress is proportional to strain. That means as stress increases, strain also increases, and we know the statement of Hooke's law that within elastic limit stress is directly proportional to strain, and therefore as here we say that stress is directly proportional to strain. That means wire obeys Hooke's law, but it is up to only point E. See here, this is the straight line. Up to this point that wire behaves the Hooke's law. Then here it is observed that in between E to E dash, here E is the maximum stress to which wire can be loaded without any permanent elongation. That means up to this point, if the maximum stress is attached, then there is no permanent elongation, there is no permanent change in the wire. And therefore that E is called as elastic limit of wire. See, this point E is called as elastic limit of wire. But after that it is observed that E dash portion, it is a curve and it is towards the strain axis, and which shows that increase in strain is more than what is expected by corresponding increase in stress. And here from that it is observed that, see here, this is E to E dash and it is parallel to strain axis, and from that it is observed that strain is not directly proportional to strain, and therefore as stress is not directly proportional to strain, that means Hooke's law is not obeyed. And also here at any point between E and E dash, if all the load is removed, then some permanent elongation occurs in the wire, and that is called as set point. See here, this is OE, it is the straight line up to which Hooke's law is obeyed. Here E dash portion, it is a curved portion and it is parallel to strain axis, therefore here Hooke's law is not obeyed. But after that, in between E to E dash, if all the load is removed, then here there is no change, and at that time it is called as set point. And when wire is again subjected to a load, that means again if the load is attached, then a new straight line as E dash is obtained, indicating Hooke's law. See here, this is the S point and this is E dash, this is the new set point. And some portion after point Y is almost parallel to the strain axis. That means strain increases without increase in stress, and just like wire flows, and this is called as yielding, or it is also called as plastic flow. That means this is the point at which the wire shows the plasticity, property of plasticity, and the value of stress corresponding to yield point is called yield stress. See here, this point it is almost that parallel to strain axis, okay, and after that wire shows the property of plasticity. And with the plastic flow, wire becomes thin and thin. We know that when continuously load is applied, then there is a permanent change in length of wire or in shape and size of object increases, and here it is observed that after that plastic flow wire becomes thin and thin, and due to that some weak points are formed, and that are called as neck points. And as the wire becomes thin and thin in the region of neck, where the strain increases speedily and stress decreases, and ultimately at the weakest point wire breaks, and that point is called as breaking point. See here, this is the ultimate stress, that is point D. Up to this wire can be withstand, it holds the total load. But after that, if the continuously load is applied or attached, then due to that some weak points are formed, and that weak points are called as neck points, and at the very weak point that wire breaks, that is called as a breaking stress. And the brittle materials like high carbon steel etc. break immediately after elastic limit is crossed. That means this elastic limit depends on the material. And the ductile materials like copper, rough iron undergo plastic deformation and its length goes on increasing, then wire breaks. And this is called the behavior of wire under continuously increasing load. Then now we solve some MCQs on these earlier PPTs. First question is modulus of rigidity is denoted by. Option A is Y, option B is K, option C is eta, option D is none of these. And as we have seen this first slide that modulus of rigidity is denoted by the symbol eta, and therefore correct option is C, eta. Second question is ratio of shearing stress to shearing strain is called as. Option A is compressibility, option B is Young's modulus, option C is bulk modulus, option D is modulus of rigidity. And as we know that modulus of rigidity, it is the ratio of shearing stress to shearing strain. Therefore correct option is D, modulus of rigidity. Third question is SI unit or MKS unit of modulus of rigidity is. First option is Newton per meter square, option B is dyne per centimeter square, option C is Newton, and option D is none of these. And as we know the formula for modulus of rigidity is tensile stress upon tensile strain, and tensile stress has the unit Newton per meter square, and that shear strain has no unit, and therefore only we write the unit of shear state, and therefore correct option is A, Newton per meter square. Question 4 is the point at which plastic flow begins is called as. And see here, the point at which the plastic flow begins, it is called as yield point. And therefore here correct option is A, yield point. This is all about today's PPT. I hope you all understand what is my modulus of rigidity, then relation between Young's modulus, bulk modulus and modulus of rigidity, and the behavior of wire under continuously increasing load. Thank you.